Hello, everyone. Mrs. Pine here, giving a quick introduction to our multi-digit multiplication and division unit that we have just begun. So, this is a quick recap of all of the things that we have done so far. When we talk about multiplication and division, we know that we're talking about creating arrays. Now, arrays are just equal rows or columns. They are made up of rows going horizontal, left and right, and columns that are going up and down. When we create an array, it is always in the shape of a rectangle. If there are any left over, then it's not an array. For example, if I have 6 tiles, I can arrange them all in one row. And I know that I have one row of 6. This is my one row. I have 6 in that row, 6 columns. That's one array that I can make with those 6 tiles. Now, if I want to make another array, I could try 2 rows. And these tiles fit in perfectly. So now my array is 2, because I have 2 rows, by 3 columns, 2 by 3 to make this. So I have one row of 6 or 2 rows of 3. But either way, these are arrays. There are none left over. If I had 7, then this would not be an array because it's kind of left over on the side here and it needs to be completely filled in. So these arrays are fantastic because they are made up of factors. Factors are the numbers that you multiply together to get another number. So if we look back at this array, our 2 and 3 are the factors that make the number 6. 6 is our product. 6 is our answer. 2 by 3 is going to give us 6. There are 6 tiles total. So 2 and 3, those are our factors. When we lined this up into an array that was just one row of 6, then our factors would have been 1 and 6. Now, another word for our product is our multiple. A multiple is the product of a whole number and any other whole number. So, our multiple here would be 6. 2 and 3 are our factors. 6 is our multiple. 2 times 3 equals 6. These are our factors. 6 is our multiple. Okay. Now, when we have two factors together like this is actually called a factor pair because there is a pair of factors together. There is 2 of them. So these are factor pairs. These factor pairs are really cool because even if I were to do a turnaround fact and switch them, they're still going to equal 6. So if I were to build 3 rows of 2 and turn it this way, okay, if I have 3 rows of 2, it's still going to give me 6 no matter which way I flip it or turn it around. These are called turnaround facts. When we take our factors and we just turn them around. But there is a big fancy name for that. Those are called the commutative property. When our factor pairs are just flipped or are turnaround facts, that is also called our commutative property, changing the order of the factors in a multiplication sentence because it does not change the product. It does not change the answer. I can have an array of 4 rows of 3 columns, which will give me 12, or I can have 3 rows of 4 columns and it will still give me 12. So our turnaround facts are the commutative property. Now, sometimes we have numbers that only have one factor pair. So, for example, if I have 7 tiles, there is only one possible array that I can make, and it is one row of 7, and that's it. I cannot put it any other way. So this is one row of 7. I cannot switch it. I could try 2 rows, but I'm going to have one left over and it doesn't work. I could try 3 rows, but I'm going to have one left over and it's not going to work. I could try 4 rows, not going to work. 5, still nothing. 6, not at all. This is it. When I only can make one array, whether it's one column of 7 or one row of 7, this is called a prime number. Now, a prime number, if we spell out prime, we can think of it as prime, this 1, and me. If I spell out prime, but I'm changing that 1 to, or that I to a 1. It is a prime number, 1 and me, 1 and itself. That's how we can remember it. When I have a prime number, it can only be divided by 1 and itself. A composite number can be more than that. So it has more than 2 factors. These are all of our prime numbers between 2 and 100. Notice I didn't say 1. 1 is not a prime or composite number. It does not exist for either of them. Why? Because 1 only has one factor, 1 times 1. So since 1 is the only factor, that's it. It doesn't exist. So 1 is neither prime nor composite. Okay, so when we are listing out our factors, we make a factor tree. For example, if I have the number 6, I'm going to make a factor tree. Like I said, I always know that 1 and itself will always be factors. We can always make one row of that number. That's always going to happen. Every number has a factor of 1 and itself. Done. Now, I could try 2 rows, and I know that I could make 2 rows of 3. And I know 2 times 3 is 6. I could try 3 rows. Oh, but wait, I already see 3 here. So I can stop. I know that I can stop because I'm just going to create a turnaround fact, and I'm not going to count those as factors. So, because I already did, I'm not going to count factors more than once. So my factors for the number 6 are 1, 2, 3, and 6. The number 6 has 4 factors. 1, 2, 3, and 6. Those are all the numbers that I can multiply together to get 6. Now, if I want to find the multiple of 6, I'm going to skip count. Whenever I want to find the multiple, I skip count. So my multiples of 6 would be 12, 18, 24, and I would keep going. When you find the multiples, all you have to do is skip count. If I want to find the multiples of 2, I would go 4, 6, 8, 10, and I would keep going. So when I'm finding the factors, I make a factor tree and try to build an array. And then when I'm looking for the multiples, all I have to do is skip count. Okay, so that's where we're at right now, and we're doing good. So just remember, when in doubt, build an array to try and find your factors. All right, guys, you got this.